All right, on to a new exercise related to generators and receivers. So, as you can see, this circuit contains two batteries, B1 and B2, and there's all this given. The first question says, the switch K is open, the switch right here is open, so specify the direction of the current I in the circuit. Now, something important to notice about this circuit is that the two batteries are in opposition. The positive terminal of B1 is connected to the positive terminal of B2, which means one of these generators is going to be a generator and the other is going to act as a receiver. So to figure out the current, we need to first know which one of these is a generator and which one is the receiver. We do this by comparing the electromotive force. Whichever one has higher electromotive force is the generator. So as you can see here, I wrote it out for you. E1 is less than E2. 20 volts is less than 24 volts. So B2 is the generator, B1 is the receiver. Now, how does this affect current? We all know that current moves from positive to negative. So we look at the positive terminals of B2, which is A, and the negative terminal of B2, which is C, which means it flows from A to C, which means it flows clockwise. The next question says, determine the value of I. So to determine the value, first of all, we don't have voltage, so we can't use Ohm's law, but what we can use is Pouillet's law. Pouillet's law says that current is equal to the sum of the electromotive force minus the sum of the back electromotive force divided by the sum of resistance. Now, because we have a generator and a receiver, or well, something that acts like a receiver, the back electromotive force is the electromotive force of the receiver, or the one that we have claimed is the receiver. So 24 minus 20 divided by the total resistance, which includes the internal resistance, will come out to 0.2 amps. So that is the current, the value of I. Our next question says that the switch K is closed, which means this is now closed. Both batteries supply electrical energy to the resistors. So what we can realize from that sentence is that both batteries are now acting as generators. We no longer have the receiver. We no longer have B1 acting as a receiver. So they told us, determine the current I1 drawn from B1, which is right along this. So we're going to use something for this question, which is known as Kirchhoff's voltage law. This isn't important, it's just how we add voltage. So UBE is equal to UBA plus UAD plus UDE. We don't have the voltages of that, but we do have something equivalent to that. So UBC can be rewritten as this, UBA can be rewritten as this, UAD is 0 because it's a wire, and UDE can be rewritten as this. And from here, it's pretty easy to solve, especially because we're trying to find I1. We simply replace each one with the value given for it, continue on with math as normal. 11I1 is equal to 20, which means I1 is equal to 1.82 amps. Our next question tells us, determine the current I2 drawn from B2, which means this current right here. We're going to solve this the same way as this. We're going to use Kirchhoff's voltage law, and let me pull this up a bit more, and this is how it's done. So we have UAC is equal to UAD plus UDC, and we know UAD is 0 because just like in the last part, it's a connecting wire. So we just replace it. We replace the ones that are not 0 with their equivalent formula. We replace each of the individual variables with the number that was given to us. We come out to 9I2 is equal to 24, which means I2 is equal to 2.67 amps. Pretty easy once you understand what's needed. Now the next question says, deduce the current in the switch. Now, how do we deduce current in a switch? Well, current in the switch means current along AD. Current along AD is the current I1 and the current I2. It's junction law. So we use junction law at A, and we add the two currents, and which we just like pulled out, which are 1.82 amps and 2.67 amps. We add them together, it comes out to 4.49 amps. So the current of the switch K, is 4.49 amps. Now the last question tells us the switch is open again and the terminals of B2 are reversed. Determine the new value of the current in the circuit. So how do we solve this? So if the terminals of B2 are switched, that means we don't have a receiver, it's all generators, but we still don't have voltage to use Ohm's law. So what we're going to do is use Pouillet's law once again, but this time we're going to use it a bit differently. In this case, there is no E, so we replace it with 0, and we just add the two electromotive forces, which are 24 and 20, which comes out to 44. And once again, we add the resistances, including internal resistance, comes out to 20. 44 divided by 20 is 2.2 amps. So that is how we find the new value of the current in the circuit.